Hi guys, and welcome back to our move design tutorial. So we continue from where we stopped the last time. So in the last episode, we've fitted the ejector pins to their correct position. So now we are going to continue. So we're going to create the cutouts in the place for the ejector pins. So let's get started. So we move over to combine, combine, select the body, and think I can pick up the ejector pins inside. I first start with the targeting sets before we cut the rest. 7, 8. That's supposed to be 10. For this one, no. That's supposed to be 10 in number. Um, no, this one. Yeah, so that 10 found the one we didn't select. So now that 10 also is select for this side soon. So at the end of the day, we'll have 20 cut. So we make sure we'll keep to this active and it's going to supposed to be a cut function. So okay, let's return on our leaflets and also cut it as well before combine. Select the 20. So now we have the 20 of them selected. Also a cut function and keep to active. Next for the support plates, same thing. Selected the 20. Okay. Now finally we cut the retainer plates. And then 20 of them. Mhm. 22 bodies. Okay. Now we are done with that. We are going to, the next thing we are going to do is to create the retraction mechanism for the ejector plates. So we go back here, go back to this plane. I think, yeah, create sketch. Now we look for a place that doesn't have any components interfering or what whatever. So I think we can use display. We can use here to hit P for projects. Mm, uh, okay. So I make an offset of -16 -16 times 2. And the other side the same thing, -16 times 2. Again, I project this side, make sure I'm touching these points. Then project this side, then make an offset, go for offsets, shortcut for offsets. I don't need to change selection. So select this point, so this will be -12 times 2. Let's go for 4. 6. That's I want to this is where the guide pillars will fit in the point for the guide pillars. So it must be a good distance away from where the screws are holding the retainer plates and the injector plate are. So you can just mirror this or do and offset again. I think they are too close together. Let's go for 12 times 4. I think that should update safe as well. So this should be okay. We'll go 16. 16. Can just mirror this again. Okay, finish sketch. We are done. Over what our utilities again. Uh, this is a guide element as well. So first of all, let's calculate the distance we need, the minimum distance we need. So from here to here, that's 84. That's excluding the head. So if you want to select it, think we can just go for 80 on the spot. So let's go again. Go to guide pillars. For this, you can create it 4 at a time. Uh, uh, 4. Diameter is 16. And let's go for 80. Let's see if that will be enough. Done with that. Let's, yeah, think that's enough. Let's do a section analysis to see if it's actually okay. Mm, yeah, that's just enough. So you can leave the section view anyways. So now we combine operation again. Before combine, this one first, show here, and select this one, select this one, select this one, select this one. Make sure keep two active. B again, record the support plates, select this one, select this one, select this one, and select this one. Yeah. Now we have our guide pillars fitted. Just like so you see the cut operation we did. Yeah, so we're done with that. So next is to create uh the returns, the die spring or return springs. So fixing the guide springs on the return springs. So now let's move over to creating uh guide the return springs of the guide springs for the mode. So to do that, we have to first check the distance, the minimum distance we need. So that's a minimum distance of 57.2. Of course, guide springs are an injection component, so we move over to the injection side. Select the 4 points to place it. Um, this one, this one. So the 32 we're using a 32 medium load spring. So since our minimum distance is 57, so the least we can do is 64. So people can wait for it to do its computations. Now it's created it on the wrong side, so we do the regular thing we do to edit joints, flip. Okay, we do it for the four of them. Edit joints, flip. Okay, go over to this side. Hmm, edit joints, flip. Hmm, this one, edit joints, flip. So let's move over to our section view. So from the section view, we see that it protrudes a little bit inside the support legs. So I have to take that backwards a little bit. So I think let's have to calculate distance which we need to go back in this case. So let's turn off our section view. Let's go to solid, create sketch. Why do you turn it this way? So think we can turn on our section view back again. And P for projects. I need to make sure I'm projecting the sketch, not the body. Go for bodies. Yeah, projecting the bodies now. Exactly, it's projecting the bodies. Okay. Well, now when I hit OK, as you can see, this is the topmost points. So take this line 90 degrees. Okay. P for project again. When you project this, now we can leave it on sketch. Project this so we don't have just so many lines. So now let's go for inspect. So that's 8.585. And just write down this, write it down somewhere. 8.585. So now we can finish our sketch. Turn off our section view. Now I need to see, we have to create a hole here so we can move it downwards. So I'm looking for a way we can do that without hiding these upper parts. So let me see how we can do that. You know what I will do? I don't want the stress of hiding that upper parts. So let's just go create sketch, project this point. I'll do it at the back, then project it onto that surface. Later on. Um, so I'll go for circle, 32 mm, circle again, 32 mm, and now I can mirror this to the other side. Mirror, so let mirror again, shoulder is there. Okay, finish sketch. Now can create sketch again. Now I would have actually seen it I created it the other way that time before. But anyways, let's continue. Projects, projects. Okay, now we can finish sketch. Hmm, can't see the cycle. I think we need to hide all the springs and even the guide pillars as well. Oh, should hide this sketch is also showing. This is the sketch we use to measure the distance. We only need this one. If I should select this one, select this one, select this one, select this one. Go here again. Select this one, select this one, select this one, select this one. So now go to the distance we measured minus 8.565. So cut operation, of course. So we have those poles there. Now let's turn on back our springs and our guide pillars. Alright, so now again, we go back to our timeline. Now I'm looking for this site. Let's turn on back our session view so we can really see, we have a clearer picture. And we can even rename the session view as well. So let's say, let's rename it. Well, yeah, I don't want to rename. So let's say ejection, can name it ejection, retraction. Uh, see if something taking, can easily identify it. Okay, so now let's move over to this side and look for that joints. As it's edit joints, maybe left view. So 8.585. 585, yeah. So again, let's hide the guide pillars to see if it's actually it's just touching the support plates because that's always meant how it's meant to be. Look for this guide pillar. Yeah, can see it's just exactly touching the support plate. So that's actually what we want. So we do it for the rest of the guide springs. So I think for this one we go for this one again. Hold down 8.565. Of course, we still need to check here to see that if we don't have to make sure we don't have any interference and you can see we don't still have any interference there. So just okay. I will move over to this side and do this side as well. Uh, what was it? The other side, the joints as 8.585. Then the last one, bring this one here. This one. Oh, we've done this before. Which one we didn't do? Oh, yeah. Maybe this one. We've done this. Doesn't mean we've done before. Oh, yeah. Yeah, yeah this one. Well, the 8.585. Now we are done putting the dash strings into place. So I'll go on over to turn off our section view and see how that fits in. Yeah, so let me hide the sketches for the springs. That is kind of making everywhere look crowded. And the sketch, and the sketch, and the sketch. And close up it, close it up, because we are seeking to create more components. Now, since we are done with that, move over to the next one. The next thing we are going to do is to create the stoppers or the ejection plates. So we move over to turn on our ejector plates. Now, so we turn on back our ejector pinpoints. So I'm going to create a support class for this thing. So I want to make sure that we still have, even after adding the stoppers, we still have enough space to put the support pillars. So what I'm going to do is I'm going to be selecting the places we have the ejector pins, because we can't put support pillars there. So after we still have enough space to put the support pillars. Yeah, looking for the oh, can he speak for projects? One is going to be there. Then at the other end, one here. Then we can just use. Let's look for underline. This one. When we come over here, this one. Yeah, so I think those can use three lines. This one, this one. Uh, okay. So now we can. I think those 6 lines would be okay for the stoppers. So now let's go back to create an arrow. For this one, minus 50, extra 100, so tiny it's still 300, a bit too much, 250, uh, that would be okay. Again, we go for the other side, uh, minus 250, and that's okay. Now we do for this line as well. Mm, 250. Yeah, that should be that should be okay, because we need some at the end, not just inside. So okay, yes again, make on that rectangular. I will take it for this side. This side, let's go minus 300. That's giving minus 350. Yeah, I think that should be And we'll do for this side. So when we are done, you can just mirror this one, select all the sketches and just mirror it to the other points. And we are done. As you can see, we have 16 of them. Can mirror it here. So I just discovered something that I actually selected some points instead of circles. So again, we just can just change that to circles real quick and do the job of mirroring them again. Yeah, so don't go ahead to mirror them, mirror the circles again. Yes, that's our mirror line. Okay, so now we can go over to creating the stoppers and placing them there. Can hide the ejector pin points. Like I said, uh, I turned on the ejector pin points, so we use the lines that have ejector pins so that we can still have some space to put main support pillars. Because if I put the stoppers, if I put the stoppers, if I put the stoppers everywhere, we might not end up having space to put in support pillars. So now let's go back to utilities. You can find stoppers in others. So if you are using many, so you don't need the one that is too big. So you say components at the origin. We are done. Now we need 32 of them. So it means you have to just do the job of creating 32 of them. So these two, I'll be checking our timeline to make sure that's number. So for now, we've created 22 of them. We have 29. So we have 30 here. 30. So use 31 and this 32. So again, we do the job of placing them in that position. So we hold this one, hold down shift, hold down shift, M for move. Make sure you're moving the components. As you can see, we have 32 components, 32 selected. So the number is correct. Now we have to uh, do the job of joining them. Don't forget to always capture position. So J for joins, just select here and place it at the points. Now my check is facing the right direction. So it need to be screwed onto the bottom plate. So this is the correct direction it's supposed to face. So okay, first then the rest. We do for the remaining 31 of them. This for drawings. Yeah. So let's continue. Now I'm done installing the 32 of them. So now Let's turn on our bottom plate and do a section view. Or let's do a section view to see if it interferes with the bottom plate. So we can use this one, tangent plane. Okay, action analysis, against inside. Okay, let's turn on our bottom plate. It's interfered inside, so we are going to combine all of them. So if we combine them, we're still going to have some pocket or spaces left. So the best thing to do is to swap. So we are still going to have some bodies left. It's not going to cut through everything. So the best thing to do is to create cycles and issue them in. So let's create a sketch to see how much distance goes inside the bottom plates. We hit P for projects, projects in bodies, project again, project is like uh, go from here to here, 90 degrees, inspect, that's 8.42. Write it down somewhere, 8.42. So now you can finish the sketch and turn off the session view. Go back, hide the bottom plate again, and turn off that sketch. Create another sketch. This time, suppose meant to be on the bottom plates. Bottom plates. There's the bottom plates. Create sketch there. Hide the bottom plate again. Now I need on that, so I'll just rotate that like that. Before projects, all the outer cycles of this one, of the stoppers. This one comes out a little bit, but it's fine, it's no issue. Let's just continue. Just everything. Supposed to be 32 of them. And looking for the remaining two. Or maybe I didn't join them. That's, let me keep searching for it. So they're right here. I didn't join them. So I need to go back to look for the sketch we did on the point and see the point I didn't join. It's one of the points. Those schools actually join that. Yes, this search J for joins. So right there. This is here. Yeah. Is there any sense of one is remaining? So look for the second points. That's I didn't join initially and join them. I think it's supposed to be around here. No, it's not there. Keep looking for it. think likely to be around here. Right, I didn't mirror one point around here. I think that's likely to be the issue. So let's check that. Take this one, take this sketch. Also make sure I mirrored this correctly. Mm, so, sorry, mirror line. Mm, oh, we have the joints here, we have the joints here. Yeah, we don't have the joints here. So, mm, yeah, this is the place. Not even here. Yeah, so this is the point in the joints. So, let's look for it again. Let's here. Use this join. You know, I don't know the distance, so I just have to do it again, select the joint at the top. Uh, over again with this one. And I think that should be complete. So now the 32 points are complete. So now I can turn the sketch back on again and look for the points I didn't project initially. I think one was here. Yeah, I projected it. Look carefully for the one we didn't project. So wasting my time looking for that. Let's just start afresh again and project everything again and make sure that this time we're supposed to have 32 in number. I'm not sure I'm selecting the autonomous layer. So the thing is because we click the edit joints, so the timeline is uh, backwards. So the timeline is not present here because those nutrients we created them before we created in Sketch. So we have to just create a new sketch again. So it updates the recent trends we added. And so that's why I wasn't able to find the new ones we added. So again, I'll create this in the what, top plane of the bottom plate. You can turn this over, yeah, hide the bottom plate. So now let's project it again. Now we're supposed to see if we have 32 in number. So after so much juggling, yeah, finally selected the 32 points correctly. So what happens is I mistakenly put two components, two of the stoppers in one position. And it will be difficult for me to trace again. So what I did, I just created another one and put it in the correct position it's supposed to be. So I'm not done yet. And let's go and hide all the stoppers and turn on the bottom plates. I don't think I'm going to be able to access it. I need to hide the retainer plates. Just hide this one, then if I extrude, one sketch is blocking us, the sketches. No, select the 32 points. Let me just hope I can be able to get inside here and select all the points. If not, we go back again and do a sexual analysis to be able to see through this position. I don't know with let's continue selecting the points. Selected 28 already. Oh, it's remaining 4. So this properly. Now again, I have to look for the other two. No, so now we have the 32 points selected. We extrude it by the former distance recorded. So that will be minus 8.40 is the cut operation. Enter. Now we have those posts created. Now let's turn on back and stop us and see if we don't have any interference now. So let's inside. Now let's go back. I think we saved the section view the last time. Let me check. I think we saved the section view the last time, yes. So now we don't have any interference. All the stopper sits right inside there. So now is to create the screws that will put them in place. Now so the diameter of this is 9 mm. So the right screw to use, or a good screw to use for this would be flathead screw, but don't think we can get a flathead screw that's the head will be that size. So let's go for the biggest. Let's see possibly the diameter of the head to see if that will be okay for us to use. If not, we'll just go ahead and use the normal socket head screw. So you see, not even very close. So just have to do Control Z. Yeah, so we have no option but to use a normal socket head screw. So since we have 9 mm, 9 mm will still be okay. So we have 32 of them, meaning uh, I need to select the inside, not from here, but can hide the bottom plates to get the view properly. On the bottom plates. So now I got in the first thing here. This was the first two I selected. Now let's select the in the fourth one. Select this one. Select this one. This one. This one. So let's try it and so that would be 12. 25. So fingers, okay, we don't need too much length. So let's put for 30. This will be phones when what's for you to do is computations. So thank God I saw it. This one was the one I had created a double joints for. So I'll just go ahead and remove it. Cozy. So now let's check. All the screws are facing the wrong side, so you have to flip them over, put them in the correct position. So this time we make an offset of the set of step will be 0 mm. Okay. Now we do it for all the 8 of them, and we'll look for this one. Heavy joints, flip, 0 mm. Okay. So now I'm done creating the 32 screws for the stop pins. So now we're going to do the process of creating the cutouts for the bottom plates. So then I do the bottom plates and I'm going to open all the screw cut bodies. Go down where we start from. Remember we did 32 of them, so I'm going to open all the 32 of them and combine it with the body, with the bottom plates. I open all the bodies, so I do before combine. You need to cut only the bottom plates and nothing else. Combine all of them. So there's supposed to be 64 two bodies we are supposed to have. Select all of them. So we have 64 of them. We don't need to keep switch to be active anyways. It's supposed to be a cut feature. So when it's done, I'll go back to edit stats. So let's go back to edit that. Make it edit feature, cut operation. Wait for it to be its computation. Now we have this, we now have the stopper completely fitted to the node. So let's turn on back our ejector plates. To see, yeah, so you can see how the stopper is into the node. So the function of the stopper is to prevent when this ejector plates retracts, is to prevent ejector plates from colliding directly with the bottom clamping plates. So the next thing we are going to do now is let's create a hole so that the knockout rod or the knockout bar on the injection molding machine can push the ejector plate forward. So now create a sketch. So this depends on the machine you are using. So you know the type of machine, the maximum the diameter for the machine. The diameter of the not expert into injection molding machine. And so just don't brush with that up to this point somewhere to check if it interfere with anything. First check. I don't think it didn't interfere with anything because I just got through it. As you know, the stopper was there or anything was there, I could have seen it. So it didn't interfere with anything. So now is to need for spaces to fit in support pillars. Because if you remember previously, if because of the bottom clamping plate screen, the screw that holds the ejection side all together, for us for the screw to fit in, we have to reduce the support plates very well by 100 mm. So that will reduce the strength of the nodes significantly. So we have to put in support pillars to compensate for that. Let's look for spaces inside to put in the support pillars. So I'll just hide the bottom plate, the retainer plate, and the injector plates. So now we can look for spaces in here. Oh, let's see the diameter of support pillars that are available. And you can just select this one. So we can go for a diameter of 50 and later we calculate the length we needed. So uh, the support pillar is supposed to be on top of the bottom pumping plate. So let me turn on the bottom pumping plate again and create sketch on the plane. Then turn it so that the other way around. Then I hide the bottom pumping plates. Let's say first plate and randomly drag the half spaces 50, 50. So I'll just do for one side, the mirror is to this side, so that's at the end of the day, they become symmetric and we have a balanced distribution of forces. So just do for this side only, then mirror is to the other side. Uh, let's continue. 21 can fit in there in the middle. Then we have 50. Uh, Let me turn on the button clamping plate and project and the ejector hold so you don't invade into that area. So uh, you've seen it, you can't invade into that area. Which is here. Uh, oh, let's continue looking for since one can fit in here. But this has to be a good distance away from here because that place is a hole. I think here 120 mm is enough distance. So I just leave it like that. Then look for another place. Let's go for one thing you want to do is one thing you want to avoid is putting too much holes around it so that because if there are too much holes around it, it's going to affect the strength of the ejector plate and the retainer plates. So we want to stay avoid that issue. And so we think the just enough. You don't end up putting too much holes So the strength of the ejector plate and the returner plate don't drops. So I'm not supposed to have this, but anyways, mirror is to this side. Okay, then it will mirror it to that side, to the other side. So if a mirror, by the way, this will be a little bit bigger than 50 mm at the end of the day. So let's mirror the okay. So you can shoot. So I turn on my ejector plate and my retainer plates back on again. So if I shoot and select all of them, so after we mirrored it, I just saw something that's this one, some tools interfered with components. So like this one interfered with the stopper and it's very close to the ejector pin on this one as well. So I believe those two some shift it inwards. So let's go back to edit our sketch. It didn't interfere with the other side anyway, but when I mirrored it to this side, it interfered. A component. And this one seems to be very close. Isn't really interfering, but not on this side. So I also shift that as well. This one too. Let's go back to the task. Let me sketch. So I'll just project it and use dimension to space this one's before projects. Whether this one, then before dimension. Uh, uh, use let's give 120, 120, and then enter. So it's supposed to update the other side as well. Let me see. Let's update it. What now means is to close to this one. Uh, let's let's make that 80. Let's see how that we look like. Yes. Mm, let's stick too close to this one. So let me just delete this one and adjust it. One, two, three here. Uh, I want them to be still very symmetrical at the same time. So what I'm going to do is let's make this 30. Let's see where it was 30 or 60. So I think that distance is okay. Then again, project this one. Then dimension to coordinate as well. I think it's already tied to somewhere. Sure again. It's already tied to one objects was mirror to this side or something like that. So forgetting which of the error will mirror, but let's just do this again. Let's just try and make sure that the apex be as symmetrical as possible. Uh, uh, let me read this line. It should so it was to be a line, so a line. Maybe we had it somewhere set to again 50. Yes, it was the reference. Delete it, delete this one. Set to paste it here. I think that's enough. Now, so this one, let me mirror this one and see where it's first. No, 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 guys, put down is okay. Then, give it this one. Let's then mirror it with this one. So, that was with this one. Yeah, I should be okay. Then, uh, delete, should I, and results delete this one. Then mirror this to the value. Now it's interfering with components. So you have to use this side. But I want them to be three, and this is kind of blocking some things. Uh, so let's find somewhere to put this one. Since we can drag this to the end now, let's go 35. See if it's touching. And then can go here. 50, too close, too close here, too close to this one. So you can just, I can't use escape in my keyboard, but it's going to stop my recording. So to do this one, you can just try and drop this one here and see. Yeah, so that should be okay there. Let's mirror it to the other side. Okay, I still need these objects. Okay, so for now, it's not interfering with anything at all. Not interfering. Let's push it again. Yeah, not interfering. If I'm even as well to some again and again, it goes into box 50. Okay. And here, right to the other side. Okay. Yeah. So, gonna shoot them. Let's sketch. And then let's turn on the retainer plate and rejector plates. And then if I shoot, select all the holes. Then I shoot all the way, to these points and take it up just to make sure it's got three spots. Must not touch the support plates. So, okay, now I have those holes. Now you need to give some tolerance to it. So it doesn't need to be engaged with the ejector plates in any way. So we give a good number of tolerance. So we can go for 12 mm since we're using a 50 mm support cable. Select this one, select this one, how that's going to deselect something, not space with this. Cancel this one, start again, and make sure I don't select any space again. Oh, the reason why I don't like this thing being automatic all the time. So that's very good. Let's change it to menu sets. Maybe I should this properly. And then we will come back to it. Turn on the sketch and put that properly again. So let's continue. Don't know the exact number we created. Let's to make sure we select all of them. That should be -1. Okay. Maybe I should didn't press put the sides. So you correct that. So let's turn back our sketch to see that this video should probably. Let me say this here. Yeah, should it properly now. And I'm going to press it now. So also going to press the return applet as well. Now give me balance. Now let's move on to creating your podcast button. So can I to sketch bar and also use this support need to get distances. Support end of the support plates. So that's 1 to 6 mm at the dots. Take that distance down 1 to 6 mm. So Now, going to continue with adding the support pillars. Mm, Over to support. So let us do it improve. Improve support pillar. 25. So the distance we have is 136, but we need the distance of 126. So it means at the end of the day, we need to make a little cutouts of 10 mm on the support plates, or do it on the uh, bottom plates. Where diameter is 20 mm, 25 mm. Also, let's make this first one and see what we need to edit in the plates. Once created this, we can hide the bottom place to see if it's facing the correct direction.